So we pass in an argument here, name, or just let's write that greeting, the greeting itself. So we can just write the greeting here, and then here we can say print. So what's the greeting that we want to write here? We can just print. So the greeting can be print greeting. We pass in that greeting there as an argument. So it's gonna grab for us. So we can say good morning, hello, good morning. Basically just that. So this is a positional argument. That's how it's called, hello, good morning. So when we call this function, we now have to pass in that argument. Okay. So when we call it with the hello, with the good morning. So it's gonna concatenate for us the way we want it. Okay. When we run this greeting, good morning. Good morning. Yeah, so hello, good morning, it concatenates for us the way we want. So this is called a positional argument. What about a keyword argument? A keyword argument, a default argument, for instance, you define it when you're creating the function. In the functions header, you can define that argument already, so that in the event, especially when the function is long, then if in case you forget, it should just run without passing an argument. So this is called a default argument. I hope you're seeing the difference. And a keyword argument is a little bit different. So keyword argument, we can just say greeting, and then we pass in the argument here. Okay, and it's still going to run the way we want it. Greetings, why is it saying it should not say, well, you get the point. So because this hello is there twice, so greeting, we can just how do we do it here? Let me just say def ages. So ages here, we can just say maybe use A to hold for us the people's ages. So we can print I am where is it? I am a old. Did I do it correctly? I am a old. So when we call this ages function, we just pass maybe 23. 23. I can just even do it. I don't have to put old. I can just say it this way, and yeah, it should run the way I want it. I am 23. Yeah. So what do I mean by keyword argument? So in keyword argument, I can pass it during the function's call. A is equal to 34. So you see, it just picks it up for us, and yeah, we have it there. So that grabs automatically for us. Okay. Yeah. Another one that I wanted to use is arbitrary arguments. Arbitrary arguments just basically means any kind of argument. For instance, I want to write a program. Let me see. I want to write. We are a pizza makers. So for instance, we want to make some pizzas. Yeah, so we want to make some pizzas, And these pizzas have different toppings, for instance. So let me create a function, def toppings, def pizza, let's say making pizza. Okay, and I want to pass the toppings, basically just those pizza lovers, you know what that means. Def making pizza, and I'm going to use this wildcard. It's normally called a wildcard, this asterisk. This means it can hold numerous number of arguments. Yeah, okay. So def making pizza, I can write here a document, so we can just say here, making pizza. Remember, I told you that it's good to document your function, your programs when they grow big. So it's good for you to document them. So what do you want to do? So I can say if topping. This is another syntax that probably you've never come across. If topping, then if topping, or let me use this. Let me use for topping in toppings. Yeah, in toppings. For topping in toppings. For topping in toppings, I can just say print topping. Okay, and then I call that function. Call that function, and then I can pass maybe what are the names of the toppings? Pepperoni, pizza lovers. Yeah, and I have it there. But there's something that I want to explain. For instance, I've not defined the number of arguments that I want to use in here. But I want to add them in future. So I can call this function with without explaining without defining the kind of arguments that I should use. We can just say green cheese, but it's gonna accept because I've used that wildcard. Green cheese, maybe. What are they? Pepperoni, green cheese, vegan, whatever this is. Oh yeah, so something like that. And still it's gonna run. Okay, so you see, I've added arguments over here. So these are called arbitrary arguments, and you see it's running the way I want it. I can even add, I can mix with maybe some positional arguments. So I can do that here for support topping, in topping print. What do I want to do here? Print, we can say, I can just like add size here, maybe 23 inches, and here maybe 24 inches. For topping in toppings, can I say, let me see this. Green cheese, vegan, it's picking everything. What did I want to do? Let me leave this for now. I've forgotten how I wanted to do it, but basically I wanted to show you we can combine both positional and arbitrary arguments. But what the most important thing that I wanted to explain is arbitrary argument. You're going to meet this when we start doing Django in object-oriented programming. You will see things like, when you come across things like args and quags, I don't think that's strange. You will see things like this and something like this and quags. So that's still Python, and I don't want to get into that. I'll get into that when we get into object-oriented programming. But basically, I wanted you to see, without defining these arguments, we can use the wildcard, the asterisk, and we can still get what we want, okay? And then there's something that I also wanted. Yeah, you can use an argument. You can opt not to use an argument. For instance, you have this function called names, And so you have here first name, last name. And sometimes this works well in certain programs where the middle name is not a must. Some people don't have it, some people have it. So if they have it, if you give them an option of inputting their middle names, okay? Many systems, they work like that. So basically, when Python sees this empty string, it's going to translate it to true. So what that means, let me write the code here. So what that means okay, let me just say if name. So if you see this expression, this I'm checking. So if name. So if name. So I'm looking for if whoever is going to enter into this system to log in, if they have a middle name. So if they have a middle name, then full name is equal to, you can even use this string formatting over here. It's gonna be first name dot title if you want, and then as last name, and then last name, and then last name. So this should be last name. The other one should be middle name. Last name. So this should be middle name. Let's make it middle name. So here also middle name. Okay, so middle name is an empty string. So Python is going to translate this empty string. If this expression, basically this, what I'm doing is if there's a name, if there's a middle name, variable in here, then it will be populated into this variable. If there's an argument with the middle name, then it will be populated into this variable. In the event that it's not there, else full name does not have middle name, then what are we going to do? So else we just have the first name and the last name. There's no middle name. Else we just have the first name, and let's put some space there, and the last name. Yeah. So if this person does not have middle name, then the second block of code is going to run. Okay. So that's how it runs. So we just call this function again. So in the call, of course, as you all know now, we pass in. We pass. But remember one thing here: when you're using this empty string, put it at the last. Let it be the last argument in the definition, not in the middle. Okay, and Python will still rearrange the way you want. So we can pass with the first name. Maybe we can say what's the first. Let's use maybe just the first name, and since and then maybe since we don't, I'll guess so. It's called just Ioma, I think so. And then the middle name maybe we put an O, because normally the middle is an initial. And this, since we are checking middle name, so it should be middle name. If middle name, so we are checking if middle name, it should run, only this should run. And yeah, it's okay. There's something that I've not done. Yeah, so let's return. Just remembered. Let's return full name. So what essentially I'm doing here, if we don't get a middle name in this is testing. So if there's no middle name, then this is going to run. The else block will run. If there's a middle name, if a middle name is found here, like for instance, this one, then the first one will run. So let's check again. Now let's see, because I've added the return statement. Thank you for your eyes. Yeah, so you see it's working now. So I'll see, we don't need these commas here because you don't put those commas when you're writing a name. because those even this even this one here. Yeah, so what I was saying, this is called an optional. So Python allows you to have this option whereby if you don't have you are not sure whether somebody has that name or not, then you can use this string and it's gonna interpret it as true. It will interpret as true if this statement finds this particular name here, and so forth and so on. So right now, if we don't supply the middle name, it's gonna run, but now this is what's running. This block will run. This else block will run. I hope that makes sense, isn't it? All right, so that is fun to me. So I wanted us to do something here. We still have 30 minutes or so. 30 minutes or so. So I want us to, okay, scopes. So what are scopes? Scopes are just where a variable lives, okay? Where a variable lives, that's what is called variable scope. For instance, this is understandable when you're doing, so we use this, which stands for local scope. That's the precedence, local. Then we have enclosing scope. We have global scope. So that's how Python runs. And then we have built-in scope. Okay, so let's go one by one. So we might have, we can define def addition. So we have, we can have this, let me just have this variable x is equal to 10, is equal to 9. And then, so this is in the global scope, it's on the top of the module, okay, or a package. So this can be a Python package, but now what is in here, it's, this is now inside the function. So what is inside the function is called local. Everything that's inside the function is called local. But in this, referring to the variable, so this variable that we will define here is called local variable because it's defined inside the variable. This one, it's defined outside the variable and it is seen by the entire program. Okay, so anything, wherever you run this program and you invoke this variable, you will get this one and you will not get this, because this global means it is visible to the entire program. A local means it's only living, it only lives its residential place or the walls the confines it can operate in, it can be accessible in, that's the right terminology, it's within this function. Okay, and then what if I define, okay, let me just do this, let me define let's say outer, and now another one, I want to define another function. So this is nested function, so this is called inner, and then in here I also define another x. Okay, so we want to see which one will run and how Python works. So this is another function, call it 78. Now let's call the inner function. So we call the inner function here, and let's call the outer function. So we call the outer function here. And let's print x now out of the function. Okay, and then let's check which one is running. Now you can see the function that is running is this one. Because I have called this function, I've printed x out of the function. So it's like this does not exist, basically. You see? So it's like it does not, that function does not exist. So you see this still runs because this is seen by the entire program. I don't know whether that makes sense. This is not coming out well. Yeah, so let's go back again. So this is outside the function. So it's visible. Anybody that wants to use it out of the program can use it. But if you want to use it inside this function, you can't. Now, let me comment this out. So we want to see which X will run. So 9 is where is not running. So then that means it's still reading. It's not supposed to read. So let me remove this one here. I will put it on Anaconda. Let me put it somewhere here so that we can see it well. Okay, so I have, can you see my screen? Can you see my screen?
Yes.
No. I've shifted to another. Let me just this distribution. All right, so I'm in here. So let's do it here so that we can see it well. Sometimes that has a problem with saving and stuff like that. Okay, so what were we doing? So if we run this, we get a 9 because the outer X is getting printed. And we can say even here, like outer or global X, global variable, global variable. So this is global variable that's getting printed, and it should print for us global variable 9, okay? Now, what if we comment this? We will get something else. So let's see. So, why print global, it should not run. Let me see. Why is it running? Yeah, so you see now it's telling us that name X is not defined. This is funny because we have X in here in the enclosed scope and in the local scope of this nested function. So we can't run this function. We are not, any program out here cannot see this function. So it's good for us because it's protecting our variables. So that's part of data encapsulation. So the data in here is safe. However, we can, if I put something here, if I want this X to run, if I say this now, I will get 78. But this is not global variable now. Now I'm running this one. Even if I global X, so I can say here X, I can print inner X here, there. So inner X and global variable is running, but let me comment this out as well because I want the inner X only to run. So now what is happening here is that the inner X is running. Because I've used this keyword, I have now changed it, even though it's a local variable, but I've now changed it to be I've now changed it to be a global. That means now I can use the contents of this variable outside the function. Okay, so that's how we can be able to go against those rules. Again, let me explain. This sometimes can confuse you. So this is any X that is out here. So this is global. It's out of the function. This is local. This is encapsulated. Enclosing scope. This is the local scope. This is the global scope. So this is visible to the entire program. This is visible to only the function. And this is also visible. This can be visible to this particular function or to this function. But we can change this to be global by using the global keyword, okay? Yeah, so I'll send you some notes on that as well. There is now the built-in. Built-ins are like those built-ins. These are just like where they import built-ins, then these are like the print and stuff like that. Built-ins. So if you run this, you get so many functions, which normally print. So we get all these stuff over here. Which you don't have to, you'll come to learn this later on. But what's happening is that these are shipped with Python. These are those methods, or what we call them, those functions that are shipped with Python. And like half of it is just for error handling. Like you can see this, or error handling. These are for error handling, and these other ones are doing other things. Like you can see input, help, map, marks, all these minimum, all these are inbuilt functions, print. So those are built-in functions, which you will see how we manipulate them later on in future. Yep. So any question? Anybody with a question? I'm sweating. I don't know. This place is very hot today. Any question? Please talk to me. Have we understood everything? Have we understood everything? I can see somebody called JKG Kelly. Who is that? So I believe that we've understood everything. So
I'm sorry, I logged in using my friend's account.
Oh,
It's
that is who?
Nick Temesi. Nikano
Nick.
Temesi.
Okay, Nick. Okay, fine. Yeah. So basically, I wanted us to share that. I don't know if Bonnie has that presentation. We have some 15 minutes. Next week, we will do lists, and then we will do object-oriented programming, and then we'll be done with Python. And then we'll jump into something else. So Benjamin will work on HTML, I think, on Thursday. So Bonnie, are you there? Or ask anything that you've not understood, please. So if now I ask you about global scopes, you can tell me what that is, where they reside, and how they can be accessed. I think you should know about that. If can somebody write for me a while loop in a function? We still have a few minutes. So Judas ran away when I'm asking questions. Okay. Yeah, so can somebody just write for me a while loop in a function? For instance, while true, first name is equal input. Please enter your first name. While true, please enter your first name. Yeah, something like that. Anyway, it breaks because of this. So if we don't put that, we get a while loop. If you don't get that, we enter while loop. So if you enter, if you put that, then it breaks. Anyways, yeah, can somebody write for me a while loop in a function? I'll call on a name. We have 15 minutes, 12 minutes to 9. Brian? Brian?
I'm here.
Can you write for me a while loop in a function?
Just a moment.